Okay, so yesterday you reviewed adding and subtracting fractions, and that was to get ready for what we're about to do, which is adding and subtracting rational expressions. So if you're still confused about how to add and subtract fractions, then you need to review that. You need to go back and look at that because you're not gonna. It's gonna be difficult to do this, or maybe this will clear it up for you. I don't know. So you can watch the video and find out. But sort of the key skill here is being able to add and subtract fractions. So like when we add and subtract fractions, when we have a common denominator, it's pretty simple. We just add or subtract the top. And that's the case for both of these problems. They both have common denominators. When I say that, I mean that this 5x squared and this 5x squared are the same. So those are, excuse me, I've got allergies. Pollen count has been ridiculously high lately, so I apologize. I'm doing my best to make this video without coughing through the whole thing. So we combine these together because it's already got a common denominator. We don't have to find a common denominator. We'll have two in a second that we'll have to find a common denominator, but here we don't need to. So we just combine them. So we're going to add because it's addition. So we're going to have, sorry, don't know what I'm just doing there. We'll have 8x minus 2, and we're adding it to 4x plus 8, and the denominator is just going to be 5x squared because we have that common denominator. And now on the top, we just combine like terms because we're adding. And we know when we add polynomials, we just combine like terms. So we've got 8x and 4x. Those go together. 8x plus 4x is 12x. And then we've got negative 2 and positive 8. Negative 2 plus 8 is the same thing as 8 minus 2, which is just positive 6. And we still have the same denominator. Notice I can't cancel anything out here. Excuse me. I could factor the top if I wanted to, and pull out a 6, and I'd be left with 2x plus 1. I just divided both terms by 6 and pulled it out front, and it would still be over 5x squared. And then I could see if I'd be able to simplify this fraction, 6 over 5, but I can't simplify that. 6 and 5 share no factors other than 1, and so I can't simplify that any further. And so that's my final answer, but also this would have been fine as my final answer. Either way is correct. Excuse me. Okay, so let's look at the second one. Also has a common denominator, so just sort of the same thing. It's also addition. So just to get kind of another example, we'll pull the numerators together. So it'll just be negative x plus 2 plus negative 3x minus 3. And that will all be over 2 because of the common denominator. Excuse me, my goodness. Take a sip of water here. I'm really sorry. Okay, so negative x plus negative 3x, so we're just combining like terms here. Negative x plus negative 3x is the same thing as negative x minus 3x, which is negative 4x. And then the 2 goes with the negative 3. 2 plus negative 3 is the same thing as 2 minus 3, which is negative 1 all over 2. So this one, again, I can't simplify. Even though 2 and 4 share factors, I can't simplify that because that 1 doesn't share a factor. And remember, this negative 4x and that 1 go together. I could pull out a negative if I wanted to on the top and make it negative 4x plus 1 over 2, but either, excuse me, either answer is right. So pretty simple, just combining like terms on the top. If it were subtraction, remember I'd distribute the negative, and really fairly simple as long as I have a common denominator. Okay, let's bring it down. Let's continue my little white squiggly line so that I can separate the two problems. Okay, so notice here, well, first off, this is now subtraction, but also there's no common denominator. So it's not as straightforward. I can't just combine the numerators. I need to find a common denominator. I need, again, to find a common denominator. That is the only way I can add and subtract fractions. I need them to be the same type of fraction or have the same denominator. So, and notice the only difference here in fractions that you'd regularly add or subtract is that there's an x involved. There's a variable of some sort. And obviously these are basic examples, and they could get more complicated, but the idea is still the same. So I need to find a common denominator. So here I've got 5 over 9, and I've got 8 over 9x. So if you think about it, well, the easiest way to always get a common denominator, and I'll show you that, is just to take our denominator here and multiply it by there and by there. And then also to take this denominator and multiply it across. So we're really cross only has one O. Now the computer doesn't want to get rid of it. We're really cross multiplying. That's what we're doing. So that's sort of the first step to find, or that's the step to find a common denominator. You could probably look at this and notice that is, if I just multiplied this 5/9 by x, x over x, I could get a common denominator. But I just want to show you the full, because the second example we wouldn't be able to do something that simple. But remember, whenever we multiply, the only thing we can multiply by is 1, because we don't want to change the problem. So as long as we multiply by the same thing on the top and the bottom of the fraction, we're good. So we just always have to do that. We can't just multiply by the bottom, and we can't just multiply by the top. We have to multiply by both. Okay, so let's do this. So we're going to have 9x over 9x. And on the top, we're multiplying it by 5. And on the bottom, we're multiplying it by 9. So I just took 9x and multiplied it by the top and the bottom. We still have this subtraction problem. And then we took 9 and we multiply it by 8. And we take 9 and multiply it by 9x. Okay, so now I just need to actually multiply. So over here in the blue, 9x times 5. 9 times 5 is 9, 18, 27, 36, 40. Sorry, I miscounted. My bad. 9, 18, 27, 45. Sorry. See, even the math teacher can't always do math. So 9 times 5 is 45. So that will be 45x. And in the denominator, 9 times 9 is 81, and also an x. Still have our subtraction that we're doing. And over here, 9 times 8 is 72. No x this time. And then 9 times 9x is 81x. Sorry. And now, I got what I want. Now I have this common denominator. So I can do like we did on the last couple of problems, and I can just subtract across the top. 45x minus 72 divided by 81x. So the thing here is I probably want to see if I can simplify this, because these are pretty big numbers, 45, 72, 81. And in my head, I know that they're all divisible by 9. So I'm going to factor out a 9 on the top, and I'm going to be left with 5x minus 8. And on the bottom, 81x is the same as 9 times 9 times x. And now I can cancel out a 9 on the top and the bottom. And so, scroll down just a little bit, give me a little more room. And now my final answer is 5x minus 8 over 9x. And that's my final answer. So, this end problem became a little more complicated to simplify, even though that wasn't a hard problem to simplify. But if we had noticed at the beginning, like I mentioned, if we had just taken 5/9 and multiplied it by x over x to get 9x as our common denominator, would have been a simpler problem. So if you can recognize that and do that, that'll make your life a little easier. But yeah, so there's our final answer there. So now let's do this one. This 1 over 3, let's scoot this over a little bit. Give me again, a little more room to work. 1 over 9x minus 3 over 5x. So, excuse me, allergies are kicking my butt. So, we need a common denominator. So we're going to do the same thing. We're going to take 5x, multiply it across, and we're going to take 9x and multiply it across. So we'll have 1 times 5x over 9x times 5x. We're subtracting, and we're going to have 9x times 3 over 9x times 5x. We want to simplify. 1 times 5x is just 5x. 9x times 5x is 45x. We're still subtracting. 9x times 3 is 27x. 9x times 5x is 45x. So if you get to this point and you don't have a common denominator, something went wrong. Either you chose the wrong thing to multiply by, or you multiplied incorrectly, which is always a possibility, as you can tell when I couldn't multiply 9 times 5 in the last example. Okay, so we've got a common denominator. So now we can just combine the numerator. So we'll have 5x minus 27x over 45x. Okay, so now, again, I need to see if I can simplify. 5 and 45 definitely share a common factor of 5, but 27 doesn't. 27 and 45 both share a factor of 9, but 5 doesn't. And you could kind of go through and list all the factors of these, but they don't share any factors. But what they do share is an x. All three have an x. So I'm going to pull out an x on the top. I have 5 minus 27. And on the bottom, it's going to be 45x still. Now I can cancel out the x's. And now I need to simplify, because 5 minus 27 is negative 22 over 45. And I do not think 45 and 22 share any factors. I think the only factor 22 has is 2. Well, 2 and 11, but those don't share any factors with 45. So that is our final answer. And this one came out with a fraction. The x's all went away. So that's our final answer. So we start by cross multiplying to find a common denominator, and then we just perform whatever operation. Then it becomes a simple common denominator problem. Hopefully this makes some sense. I apologize that I've kind of been, excuse me, there I go again, that I've kind of been coughing the whole time, but hopefully this was understandable. For basic problems with adding and subtracting rational expressions, whether or not they have a common denominator.